All right, one last graph, a hole at x equals negative 2. So y equals, need to have an x plus 2 in the top, gotta have an x plus 2 in the bottom as well. Vertical asymptotes at x equals 3 and x equals negative 4 and x equals negative 6. Holy moly. So I need an x minus 3. I need an x plus 4, and I need an x plus 6. That gives me all those x-intercepts. I'm sorry, all those vertical asymptotes. I need an x-intercept at 2, so x minus 2, and negative 5, so x plus 5. And I need a horizontal asymptote of y equals negative 3 halves, which means I need a negative 3 in the top and a 2 in the bottom. All right, does this do it, though? That's the question. No, it does not, because the degree of the numerator is currently 3, the degree of the denominator is currently 4. The degrees need to agree if we want the coefficients, negative 3 halves, to be our horizontal asymptote. So what do? Well, I've got 3 in the top and 4 in the bottom, so I need an additional factor in the top. So let's just square one of these. Okay, so x plus 5 squared. Now I just need to graph this and make sure that everything agrees. Okay? So let's start marking things. Negative 2, that's where I'm going to have a hole. Positive 2, I'm going to have an x-intercept. Negative 5, 1, 2, 3, 4, 5, I'm going to have an x-intercept, and that x-intercept is going to bounce. In the bottom, I have an x minus 3 is going to give me a vertical asymptote at positive 3. I have an x plus 4 is going to give me a vertical asymptote at negative 4, so I'll dash that in now as well. X plus 6 is going to give me a vertical asymptote at negative 6, so I'll give myself a little more x there. 1, 2, 3, 4, 5, 6 right there. Dash that in. And then finally, a horizontal asymptote at negative 3 halves. So if that's 1 and that's 2, negative 3 halves, it's right in the middle. So we're going to look something like that. So we've got the bare bones graphed now, and we can figure out where we need to go. Easiest place to start is all the way to the right or all the way to the left. Both of those have to be down to start. Again, using that same idea of to the left of our leftmost vertical asymptote, I don't have any x-intercepts. And to the right of the rightmost vertical asymptote, I also don't have any x-intercepts. So I have to be down, because if I were up, I would have to cross the x-axis when approaching that horizontal asymptote. So there we have that. And now if you look at the denominator, in the denominator, the multiplicity of every factor is 1, an odd number, which means as I cross to the other side of every vertical asymptote, I must always switch the infinity that I approach. What do I mean? Well, I mean if I start to the left, since that tail is going down, this tail has to be up. So I come down, I hit that 0, and I bounce, because that multiplicity is an even number. And then since the tail to the left of that vertical asymptote is up, my tail to the right has to be down. So this piece has to start down there. I have to come up, I have to come up, I have to curve over, I have to hit that x-intercept. I have to cross at that x-intercept because its multiplicity is 1, and so I have to curve up then to that asymptote. And that agrees with the behavior, since that ended up, the other one ends down, which is what we started with. So here we go, we have that. Last thing we need to do is just show this hole in the graph with an open circle right there, and we've done it. We're rock stars.